All right, so now we're moving into section 2 where we're going to talk about representing a function. So recall that a function is when our input has exactly one output, or when our x value maps directly to just one y value. And so today we're going to talk about all the different ways that we can represent a function. And so let's go ahead and get into that. So we can represent a function in 4 ways. We have our ordered pairs. And so remember, any set of ordered pairs is considered a relation. So we have our ordered pairs of x comma y, input comma output. We can do a table. So again, it's the exact same points shown in a table. We could make a graph. This happens to be a linear graph. It makes a line. We know that it's a function because I can use that vertical line test that we learned in 7.2 to determine whether or not it crosses, our vertical line crosses our function in only one place. And then we have our rule, or more commonly considered an equation. We can write an equation. And so all of these can represent a function. As we look at this one, all 4 of these represent the same function. So there are many ways that we can show these, well, many being 4 ways that we can represent a function. So let's go ahead and get started. During 1 hour of walking, you burn about 257 calories. The total number of calories you burn is a function of the number of hours you walked. How can you represent this situation in 4 different ways? So we talked about our 4 different, our list of ordered pairs, our table, a graph, and a rule. I think the easiest one for me to start off with is a rule. For you, it may be listing some ordered pairs or creating a table and then going into the graph. But to me, it's that equation. And I understand. I've been working with math longer, so I read something like this and I see it. So I know I'm going to have a y equals. It says during 1 hour of walking, we burn about 257 calories. To me, that says for every hour of walking, I'm going to burn about 257 calories. And so that for every hour, I'm going to have 257 x representing the number of hours, and y representing the number of calories burned. And so there's my equation. I can now easily use that equation to create myself a table. So we can have our x values and our y values. And so if I walk 0 minutes, then I burn 0 calories. Simple. If you remember from chapter 5, this is what we would call a proportional relationship because we start at 0, 0. If I walk 1 hour, then I'm going to burn 257 calories. If I walk 2 hours, I'm going to burn 514 calories. And again, I've already worked out the problems, but I am just taking when x is 2, plugging it in, taking it times 257. So now I'm going to take, if x is 3, so 3 hours, take that times 257, and I get 771. And I go 4 hours, then I'm going to burn 1,028 calories. So there's my equation. Here's my table. There's 2 representations. I can then make my table into a list of ordered pairs. And so my list of ordered pairs would be just matching those up, 0, 0, and then 1, 257, and 2, 514, and 3, 771, and 4, 1028. And from here, now I'm just going to graph those points onto my graph. And so down below is going to be my time. So we're going to have time down here. And over here, we're going to have calories burned. Cal burned. And I'm going to count by ones on the bottom. And I'm going to count by 200s going up. So 200, 400, 600, 800, 1,000. And so a lot of my points are going to be estimations. So I'm going to start at 0, 0. And then 1 is going to be about, so halfway is going to be 300, so about a quarter of a way through. For 2, we're at 514. So here's 4, halfway is 5, so just above the halfway mark. For 3, we're at 770, so here's 6, 7's halfway. We're almost to that 800 since we're at 70. And for 4, we got 1,028, so 1,000 just above it, because halfway would be 1,200. And then, because remember when we talked about proportional relationships, we had 2. We could be continuous or discrete. I can figure out I'm still going to burn calories for every minute that I walk. And so this would be, we would do our best to draw a straight line through here because this is a continuous situation. I can find for each minute, therefore I would have a line. But those are the 4 ways. We just represented that paragraph in 4 different ways. Our equation, y equals 257x. Our table, the t-chart, x and y, and each of those points. The ordered pairs created from the table, and then from those ordered pairs, we created the graph. And so those are our 4 ways of representing a function. So example 2, which table could be a view of the function represented by our graph? So the easiest way here is to just kind of look at each of these tables and match points to the graph. So here we start with 0, 0. Well, that is a point on my graph, so that's good. Our next one is 1, 3. So 1, 1, 2, 3. We don't have, our line is not going through at 1, 3, so it cannot be this first one. And there's no point to checking the other points because it doesn't work for that one. So again, 0, 0 works. 1, 1, 2, negative 3. That one works. 2, so here's negative 3, negative 4, negative 5, negative 6. So far that one works. Let's double check on this one. And if it doesn't work, process of elimination tells us it is exactly the middle one. So if I go to negative 3 and up to 6, so 1, 2, 3, 4, 5, 6, I don't have a point here. So since this one does not work, this entire table does not work. And so that does mean that our middle table is the function, or is the table that represents the function that is our graph. And that is the end of representing a function. So, yay, 7.2. My mouse isn't working.